In this problem, it says the blood platelet counts of a group of women have a bell-shaped distribution with a mean of 257.8 and a standard deviation of 65.6. So we're going to use the empirical rule. So I've drawn a bell-shaped distribution, and what I'm going to do is label the mean to start off with. So that's the 257.8. And then I'm going to add 65.6, which is the standard deviation, to get to one standard deviation above the mean. And I've already done that off to the side. We have 323.4. If I add another standard deviation, I get to 389. And then one more standard deviation takes me to 454.6. Then I'll go to the left and subtract 65.6. So we get 192.2, 126.6, and 61. So now I can answer the questions. It says, approximately what percentage of women in this group have platelet counts within 3 standard deviations of the mean, or between 61 and 454.6. So the empirical rule tells us that within 3 standard deviations of the mean, 3 below to 3 above, we have almost all of the data. You can see that that normal curve comes down to the very at the bottom there where the axis is. It actually is supposed to be getting closer and closer, but never actually touching. There should be a small gap there, but you know, when you draw with a computer, that's what happens. So we don't have 100%, but we do have 99.7% between 3 standard deviations below the mean to 3 standard deviations above the mean. So we see that. Okay. Next, it says approximately what percentage of women in this group have platelet counts between 126.6 and 389. So I'm going to take out this 99.7%. Now we're looking at 126.6 to 389, and the percentage that fall within 2 standard deviations of the mean. Still, most of the data, it's going to be 95%. So we see that that is the answer to part B. So this empirical rule is also sometimes called the 68, 95, 99.7% rule, because it's 68% falling within 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. So that's how you do that problem.